Hello friends, welcome to video lecture on kinematics of machinery. In the today's session, we'll continue with the problem on relative velocity analysis of mechanisms by relative velocity method. So here is the problem with us. The mechanism as shown in figure has the dimensions of various links as follows. AB equals to DE, here the AB is given, AB equals to DE DE equals to 150 mm, and then length for the BC and CD is given 450 mm. Then next one EF. So here is the EF. This EF with us 375 mm. Then crank AB makes an angle 45 degree with the horizontal and rotates at A in clockwise direction at uniform speed of 120 rpm. The lever DC, D is here and C is here, okay. Lever DC oscillates about the fixed point D, here is the point D, which is connected to the AB, which is connected to this AB by the coupler BC. The block F moves in a horizontal guides being driven by the link EF. Determine the velocity of the block F, then angular velocity of link DC, rubbing speed at the pin C, which is 50 mm in diameter. Okay, so first of all write out the given data. So here AB, crank AB rotates with 120 rpm. This information with us. So here NAB equals to 120 rpm given. Okay. So therefore, what's about the omega AB? Omega AB is nothing but the 2 pi n divided by 60. So 2 pi n with us 120 divided by 60. After doing calculation, you can get the value for omega AB. So in this way, you can get the value for the omega AB, 2 pi n divided by 60, 120 with us. So we can get the 4 pi radian per second. Okay. So after this, get the linear velocity of the same link, that is BA equals to omega BA multiplied by BA. So this is the relation between the linear velocity and angular velocity, V equals to R omega. Okay. So here the omega with us 4 pi and BA with us 150 mm. BA or AB, length for this AB is given 150 mm. So by multiplying 10 raised to minus 3, convert into meter. Okay. So in this way, you can get the linear velocity as 1.885 meter per second. So once we get this velocity, move towards this one diagram. So first of all, draw the space diagram. So here in this case, length for the AB is given. So the various distances between the various points as well as the length of the links with us. Okay. So account that, first of all, take this one A point here. So this makes an angle 45 degree. Okay. So first of all, draw the reference line here. In this way, first of all, draw the reference line. Okay. And just mark one point on the same. Then just here mark one point that makes an angle 45 degree with the horizontal line. So this point is nothing but the B point. Now see the length for the every link. 150 mm is the shortest. Here the 100 mm length with us is the shortest one. And if you just see this one, BC is the largest one. So you can easily take the scale for this one as if I just say here the configuration diagram at the bottom of this one, just write the configuration diagram or the space diagram. And at the bottom of this one, you can write the scale in this way. Scale equals to, here the 150 mm length is given. For this 150 mm, just I'll consider as 50 mm. Now in this way, take a scale. 150 mm equals to 15 mm. In this way, you can get the scale. So here the length for this one with us 15 mm. So once we get this one 15 mm, so next to this one just mark the various point. So whatever the distance between this line and this one given 375, so according to that just mark one point at a distance of 375. Okay, draw one line parallel to this line. Okay, so this distance with us 375 mm. Apart from this one, the distance of other point is also given. So with respect to this point, the location of the D is also given. So with respect to this one, here is the 370, 375. So at a distance of 375, okay, with respect to this one, the D point with us, just mark this D point. Now next to this one, just take BC distance in compass. The length for the BC with us, so length for the BC with us 450. So here the B point with us, just mark one point at a distance of 150 mm. At the same time, length for the DC is also with us 450. So by taking this as a reference point, just mark here. Okay. The intersection of both of this one will occur at this spot. Okay. This point is nothing but the C point. So join this C point with the B point this way, and join this point with the D point. The next one, with respect to this D point, the location of path followed by the slider with us. Okay, so that is located at a distance of 100 mm, means as per our scale 10 mm. Okay, so here just draw one line parallel with this line. Okay, so once this line drawn by us, next one, see the length DE with us 150 mm. So at a distance of 150 mm, mark one point in this way. And what's about the EF? Length for the EF with us 375. So take this distance in compass 375. Take this distance in compass as 375. Just mark on this horizontal line. Okay, so this point is nothing but the F point. Join this point with this one. This is nothing but the E point. This indicates the F point. So F point here connected with the slider. So here the slider like this. Now just say our next target is to draw the velocity diagram. For that, observe this diagram. So in this case, this A and D is belongs with the fixed point, because here the D point is a fixed one and here is the A point. Okay, that is also a fixed one. This rotates about this point in clockwise direction, this information given in the problem. So whatever the points available with us that belongs with the fixed point, just mark them at a single point like this one. Just mark this one at a single point. Just give the name for that AD. So once the name is given AD, now move towards this one. So what's about the AB? So here the linear velocity of the AB already with us 1.885. For that, let us assume some suitable scale. So here I'll assume for this one as 50 mm. Okay, so draw one line parallel to this one whose length is 50 mm. In this way, just roll your roller scale, and at a distance of 50 mm, just mark one point. So this point is nothing but the next one, B point. So once we get the B point, already the D point with us. So this one, C also lies on this one, a D point. So draw one line perpendicular to this one, perpendicular to this D line. From this D, draw one perpendicular line. In this way, you have to draw the one line perpendicular to that D point. In this way, you just draw this line. So once this line drawn by us, now move towards the next one. We know the B point. Okay. Now with respect to this BC link, draw one line perpendicular to link BC. In this way, just here we are drawing our line perpendicular to BC. For that, just roll this roller scale in this way. This way, just roll it. Just extend this line in a such a way that the intersection of the previous line occurs with this line. So intersection of both of this line is nothing but the C point. At the same time, just give the name for the velocities. Towards B, we are showing is here, this is nothing but the VBA equals to VB. Now towards from B to C, we are showing, means this must be CB, and with respect to this one, D is connected with the C. In this way, we can just show VBC. Now we just see the slider follows the path in this way. So whatever the path followed by this slider, you have to just show the same path on the velocity diagram also, but where that fixed point is shown, from that pass one line in this way parallel to path followed by that slider. So once this point over, now move towards the another point. Here if you just say E point lies somewhere on this link CD, means to locate this E on this link CD, you need to just take the ratio in this way. For that, just mention here. So here we can write the ratio like this one. E lies on CD. So here this E lies on CD. Therefore, divides the vector BC in E in the same ratio as E divides CD. Okay, that is, we can write in this way: CE divided by CD equals to CE divided by CD in this way. Okay, so in this way we can get the length CE. So what's about the length CE? For that, CE, capital C already with us, C and this one CD. So what's about this CE? CE is nothing but CE, length for the CE with us. So total this length is given 450. So out of this one with us 150. So this must be 300. 300 divided by length for the CD with us 450, multiply by CD length. CD length, just measure that length from this velocity diagram. So from this velocity diagram comes near about 6.3. 6.3. So 6.3 multiplied by this one 300 divided by 450. So after doing calculation, we can get CE as 6.3, this one in centimeter. 0.3. So we can get, sorry, in terms of mm, multiply by 300 divided by 450. So we can get the 42. So CE with us 42 mm. So mark one point at a distance of 42 mm with respect to this C point. At a distance of 42 mm, just mark one point. Okay, so once we can get the this one E point, so our task is very easy after this one. So E point, this one EF link with us, so already the E point with us, so draw one line perpendicular to this one EF from that E point that intersects on the horizontal line. Okay, that intersect the horizontal line at this spot. So what's about this one? This is nothing but the path followed by the slider. So if you just see, when this will start rotating into this direction, the tendency of this one slide to move towards this side. So what's about this one? This is nothing but the VF. What's about this one? This indicate the F point with us here. So towards F we are showing, means this must be VFE, like this. So once this point completed, then easily solve the next steps. Now measure this from the velocity diagram. This is near about the 19 mm. So if the length on this one velocity diagram is 19 mm, for that already we have considered the scale for this 1.885 meter per second. We have considered as 50 mm. Okay. So here the mention velocity diagram. So from this diagram, so if this comes 19 mm, I'll just do here the rough calculations for this 1.885 meter per second, 50 mm with us. So how much is the length for this? How much is the velocity for this one? Okay, by cross multiplication we can get 0.716 meter per second. This x is nothing but the velocity. So in this case we can get the velocity f, the slider. Now the velocity of slider f, that is Vf, equals to 0.716 meter per second. Okay, then next one, our target is to calculate the angular velocity of the link DC. For that, just concentrate on the angular velocity of the link DC. Means first of all, just get this one, this velocity, and after that so here we can get near about the 60 mm. Okay, 60 mm. So with the help of this scale, for the 60 mm, how much is the velocity? So we can get by measurement velocity of link CD, that is V DC, equals to, for measurement and doing calculation, we can get the 2.26 meter per second. Okay, so our target is to get the value for angular velocity of the same link. Now the angular velocity of CD, that is omega CD, equals to VDC divided by CD. This one with us 2.26. Then for the CD with us, CD with us 450 mm, let's multiply by 10 raised to minus 3. We can get as 450 multiplied by 10 raised to minus 3. You can get 5.02 equals to 5 n per second in this way. Okay. Now next target is to get the rubbing speed at the pin C, which is 50 mm in diameter. Now focus on this one, C point. So C point is here. Rubbing speed at C is angular velocity at this one, angular velocity of the BC and angular velocity of the CD. You need to consider it. angular velocity of the BC minus angular velocity of the CD multiplied by radius of spin. Radius of pin. This is the formula. Okay, when both the this actually moves into this direction, means this will start moves into this direction. At the same time, this start move in the same direction. When both the pins, both the links moves in the same direction, you have to just subtract the angular velocity of the next link from the previous one. So omega BC minus omega CD multiplied by radius of the pin. So omega BC, CD with us 5 radian per second, omega BC. Omega BC you can get with the help of this one. Measure this and convert into true scale. So this is about near about the 60 mm. Okay, so in this way if you convert this one, so here omega BC equals to, sorry, before that just get the value for BBC, that is linear velocity. So linear velocity you can get near about so omega BC, if you just measure this one, you can get the near about 60 mm. So as per this scale we are selected, you can get the 2.26 divided by, so this indicate the linear velocity of the link BC. Okay, what's about the angular velocity of the link BC? Angular velocity in this case is nothing but the 2.26 divided by 0.45, because 450 mm length is given for that link BC. To do the calculation, you can get the 5 radian per second. Now from this relation number 1, you substitute the value of omega BC and omega CD. So what we get here? Rubbing speed at point C is nothing but 5u minus 5u multiplied by radius of the pin with us 50 mm. In diameter given means here 25u multiplied by 10 raised to minus 3. Okay, so 5 minus 5 is 0. So rubbing speed at point pin C we can get as 0 meter per second. This is the answer.